Hey guys, today we're going to be looking at properties of logarithms. So the first thing that we're going to look at is exponents and logs of the same base. So I'm going to start by filling this chart in up here with a couple of rules for exponents and logs of the same base. The first one we want to look at is log base x of x to the c. So in this example, I see that the base of the log and then what I'm taking the log of are the same. If this happens, they essentially just cancel each other out and you're left with c. The same thing works in an exponential form. So if I have b to the log base b of c. So again, I have the base of an exponential function to the log of something that has the same base that I started with. The same thing that happens up here happens here. So the base and the log cancel each other out and you're left with just c. These same two rules apply for the natural log as well. Remember that the natural log is really just a log with a base e, but instead of writing it in this way, we use ln. So if I have ln of e to the c, since this is a log with a base of e, and then I'm taking the log of something that has a base of e, they cancel each other out, just like with the common log, and you end up with just c. The same thing works in an exponential form. So if I have e to the ln of c, since this is a base to a log of the same base, they cancel each other out, and you're left with just the c value. Here are a couple of examples of that. In the first one, I have ln of e to the x. So that's a log with a base e, and you're taking the log of something that has a base of e. So those essentially just cancel each other out, and you're left with x. Over here, I have an exponential, 5 to the log base 5 of 2x minus 1. The base and the log base match, so they cancel each other out, and I'm just left with 2x minus 1. E to the ln of x plus 7. A base and a log of the same base. They cancel each other out. I'm left with x plus 7. Log base 9 of 9 to the 6th. The log base and what you're taking the log of match. They cancel each other out. You're left with just 6. Here, something interesting to note, I have log of 10 to the 25th, and there's no base specified. When they don't specify the base, that implies a base of 10. That's the common log. So this really says log base 10 of 10 to the 25. The base of the log and what you're taking the log of match, so they cancel each other out, and you're left with 25. Last one, ln of e to the 5x, log base e, and what you're taking the log of match. They cancel each other out. I'm left with 5x. So those rules are just going to apply when you have exponents and logs of the same base. What we're going to look at now are our other log laws. So the first one I want to look at is the logarithm of 1. So if I have log of 1, this says log base 10 of 1, right? But I can really make this rule apply for any base. So say this is log base x of 1. So this rule can apply for a log with any base. So say I have log base x of 1. That says x to some power is equal to 1. The only thing that I can raise a variable, a number, anything to and get 1 is 0. So whenever you're taking log of 1, no matter what the base, you're always going to get 0. That would also apply then for the natural log. That means the natural log of 1 is 0, or ln 1 is 0. For the logarithm of the base, that says if I have log base x of x. This looks very much like this rule up here, right? I have the log of a base, and I'm taking the log of the same thing. So since they match, up here I was taking the exponent. The exponent here is just 1. So there you go. Log base x of x is 1, which means for ln, if I have ln of e, right, log base e of e is 1. Next rule, multiplication. If I have log base x of a times b, so I'm taking the log of any base, but what I'm taking the log of, I'm multiplying. I can take that and split it up into addition. So if I have log base x of ab, I can split that up into addition, and it becomes log base x of a plus log base x of b. The same thing applies for my natural logs. If I have ln of a times b, I can split that up into ln a plus ln b. For division, if I have log base x of a over b, so I'm taking the log of division, I can split that division up into subtraction. So this becomes log base x of a minus log base x of b. The same rule applies for ln's. So if I have ln of a over b, that becomes ln of a minus ln of b. And last one, logarithm of a power. If I have log base x of a to the c, that exponent can become multiplication in front. So c log base x of a. And the same rule applies for my ln's. If I have ln of a to the c, that exponent becomes multiplication in front. So c ln a. Let's move on to a couple of examples using these log laws. So I'm going to skip around a little bit in each section. So in part 1 here, I'm going to do 1, 3, and 5. The directions here are evaluate and simplify. So in number 1, I have log base 25 of 125. I know that I can rewrite 125 as 25 squared. And now, using my logs of the same base rule, I know that if I have log of a base and what I'm taking the log of match, they cancel each other out, and I'm left with 2. For number 3, same idea. I can rewrite 81 so that it has the same base as the log. I know that 81 is equal to 3 to the 4th. So now, using my log laws, if I have log of a base and what I'm taking the log of match, they cancel each other out, and I'm left with 4. For number 5, I have e to the x minus ln x. Since I'm subtracting exponents, I know that I can go backwards and rewrite this as division. So I can write that as e to the x over e to the ln x, right? That comes from our exponential rule that says x to the a over x to the b is equal to x to the a minus b. So we just used this rule, but we went backwards. So if I have e to the x over e to the ln x, in the bottom here, in the denominator, if I have e to the ln x, the e and the ln cancel, and I'm left with just e to the x over x. In part 2, the directions are to write as a single log and find the value of the expression. So in number 1, I see that I'm adding 2 logs. If I add logs, that's the same thing as multiplying them in 1 log. So I can rewrite this as log base 12 of 9 times 16. I know that 9 times 16 is 144, so I have log base 12 of 144. I can rewrite 144 as 12 squared. So now if I have log of a base and I'm taking the log of the same thing, they cancel out. I'm left with 2. Part 3. My directions are to expand each expression as a difference, sum, and or multiple of logs, and find the value of the expression. So when I'm looking at this first problem, I see the division first. So I'm first going to split that division up into subtraction. So I have log base 3 of 9 minus log base 3 of 27. I know that I can rewrite the 9 as 3 squared. So now I have log base 3 of 3 squared. And I can rewrite the 27 as 3 cubed. So log base 3 of 3 cubed. So now I have 4 times log base 3 of 3 squared. The log base 3 of 3 cancels. I'm left with just the 2 in the exponent. And the log base 3 of 3 cancels. I'm left with the 3 in the exponent. So now I have 2 minus 3 is -1 times 4 is -4. In part 4, my directions are to write in terms of log A and log B. In this section, I'm going to do 1, 4, and 6 to start, and then we'll do a couple more on the last page as well. So in number 1, if I want to write this in terms of just a log A and a log B, so I want to split this up, I'm first going to take this multiplication and write that as addition. So that becomes log of A squared plus log of b. Now, I don't have just log a over here. I have log of a squared. So now I can use my exponent rule that says the exponent becomes multiplication in front. So I have 2 log a plus log b. Number 4, I have log of the square root of a over b. I'm first going to rewrite this radical as an exponent so that I have log of a over b to the 1/2. Now, since this whole thing is being raised to the half, I'm first going to bring the half to the front, multiplication in front, so that I have 1/2 log of a over b. Now I'm going to attack that division. So now I'm going to split the division up into subtraction. But it has to be 1/2 times this whole thing. So I'm going to need either brackets or parentheses. Remember, those are interchangeable and it doesn't matter which you decide to use. So now when I split up the division, I'm going to have the 1/2 on the outside and then log a minus log b. There we go. Now I'm in terms of log a and log b. In number 6, if log base 10 of 3 equals x and log base 10 of 5 equals y, express log base 10 of rad 3 over 5 squared in terms of x and y. So I'm first going to have to start with this expression and just start expanding it out. So if I have log of rad 3 over 5 squared, I'm first going to split this division up into subtraction. Now notice, this is different from number 4 because in number 4, this entire quotient was being raised to the 1/2. In number 6, each part of the quotient, so the numerator and the denominator, each have a different exponent. So that's why I'm not going to worry about the exponents first. I'm going to worry about the division first. So when I split up the division, I have log of rad 3 minus log of 5 squared. From there, I know that rad 3 is the same thing as 3 to the half, so that exponent can come in front. So I have 1/2 log 3 minus this exponent can also come in front as multiplication. So minus 2 log 5. Now I'm in terms of log 3 and log 5. I know that log of 3 is x, so I have 1/2 x. And I know that log of 5 is y. So 1/2 x minus 2y. There we go. There's my expression in terms of x and y. So on number 7, I have solve for n. Log base 4 of 64 minus log base 4 of 16 is equal to log base 4 of n. So the first thing that I'm going to do is combine these two logs on the left-hand side to become one log. So if I have subtraction, I can write that as division. So log base 4 of 64 over 16 is equal to log base 4 of n. I know that 64 divided by 16 is 4. And if I have log base 4 of 4 on the left side equal to log base 4 of n on the right side, I can really just match these up, right? The 4 and the n are in the same spot. So that means that n is just equal to 4. In number 10, I have log base 2 of x is equal to a and log base 2 of y is equal to b. Express log base 2 of the 4th root of y over x cubed in terms of a and b. This one is similar to number 6. So the first thing I'm going to do, I'm just going to rewrite that whole big expression they have there. I'm first going to attack this division by splitting that up into subtraction. So log base 2 of the 4th root of y minus log base 2 of x cubed. I know that the 4th root is the same thing as y to the 1/4. Carry down the rest of my expression. And now these exponents can just pop in front. So I have 1/4 log base 2 of y minus 3 log base 2 of x. I know that log base 2 of x is equal to a. So I have a minus 3a over here. And I know log base 2 of y is equal to b. So I have a 1/4 b over here. So my final answer is just 1/4 b minus 3a. That's it for properties of logs. If you guys have any questions, feel free to leave them in the comments below. Have a great day.